The recording has started. So.
You still haven't, I don't see your screen, ma'am.
Okay. I'm showing my screen. Can you now see my screen?
Yes, ma'am.
Now, this table is very important. Ooh, it's messy. Can you see this table clearly, guys?
Yeah, we can see it, ma'am. This
Can
is
you
from
please?
last week's work.
Yes. Can you please open it? It's on page, because I have the study guide next to me. It's on page 2. Just open it for me because it's very important that we see how it works. Just open it on the side so that when I ask you, you're able to answer it. Are we all on page 2?
Yes, ma'am.
Okay. The others?
Yes, ma'am.
Yes. Thank you, because I'll need your help. Now, remember that last week we started with the standard integrals, right? Just the same way when it comes to differentiation, we started with the standard derivatives. Now, today, the first two important ones are when you integrate. Okay, why is the pen not writing? Let's see here. There we go. So the first two ones, it's number 6. When you're integrating a derivative of a function times the sign of a function, dx, we know that this is equals to minus cos of f of x. You know that, right? Because if you differentiate this part over here, you'll get what is under the integral sign. Now, the other one is when you have the integral of the derivative of a function times the cos of a function f of x dx, then this is equals to sine of f of x plus c. Because if you differentiate this part over here, sine f of x, you will get what? F of prime of x times cos of x. So those are the two that we need for now, right? Now to recap, last week we said that if you have x to the power of something and you're x to the power of n, where n is a number, right? So, and then when you are, what's this? When you are integrating x to the power of n, then this will be what? X to the power of n plus 1 over n plus 1 plus c. Now remember, n should not be equals to -1 because once n is equals to -1, that's division by 0, and therefore it's undefined. Are we all together there?
Yes, ma'am.
I need 3 yeses.
Yes, ma'am.
Thank you. Now, there's another one that we need to recap on. We say that if we are integrating a function to the power of n, f of x, times the derivative of a function, dx, then this, we can actually, the integral of this is actually equals to f of x to the power of n plus 1 over n plus 1 plus c. Remember that n should not be equals to -1. Do you remember that?
Yes, ma'am.
Thank you. Now we said when we're integrating a function, the derivative of a function over a function itself, dx, then this is equals to ln of f of x plus c. Are we all together?
Yes, ma'am.
So that's the recap of last week. So it means that we will need this. We will need this, including what we have learned last week to actually solve today's work. Now let's go back to our notes. So they say integration, trigonometry integrals. So the outcomes, at the end of this learning unit, you should be able to solve integral of powers of trigonometric functions using trigonometric identities. So therefore it's important for you to remember your identities. Now solve integrals of products of trigonometric function using trigonometric identities. So at the end of the section, you should be able to solve the power of n, sine to the power of n, cos to the power of n, and sine times cos to the power of n and to the power of m and n respectively. Now, these are the identities, right? So they say the following list of trigonometric identities will be used to solve integrals of power of trigonometric function. So you remember those identities and make sure that you remember them, right? So now they say, okay, fine. 1.1, they say that if you have sine to the power of n f of x, this is what you're going to do. The first thing is you look at your n, your power there. Is n positive? Is n even or odd, right? Then you will apply a rule. Now they say if n is even, you remember your even numbers, isn't it?
Yeah.
Yes, ma'am. Thank you. So if n is even, meaning that that number you can divide by 2 and give no remainder. Therefore, you will use the following identity. This identity over here. Make sense?
Yes.
Yes.
ma'am.
Thank you. So let's take a screenshot. Let's do this example.
I got a question though.
Mm-hmm.
Oh, what if n is a fraction?
What if n is a fraction?
Hmm.
In most cases, they look at n being even or odd, right?
Mm-hmm.
So I've never came across a point where n is a fraction, right?
Hmm.
And sometimes if n is a fraction, okay, wait. When you are finding a derivative, did you have a fractional derivative?
Excluding if it's tied to x or y, like if it's a constant.
No, I do understand, but then remember that when you were talking about derivative, you say the first derivative, the second derivative, and the third derivative, right?
Uh-huh.
You never had a half derivative.
Yet.
Yes, it's not part of your module.
Oh, okay.
A half derivative is a fractional derivative, which is something else.
Oh,
Like there's
interesting.
1/3 derivative. That's called a fractional derivative. That's something else. So
I
here
see.
we'll be considering the numbers n, where n is actually even or odd and they are integers.
Oh, I see. Interesting though.
Yes, because sometimes trying to integrate sine to the power of a half might not be easy by just solving using the simple techniques that we have learned here. So meaning that you will need to find you need to use numerical integration.
I see, ma'am. Okay.
Yes. So it's not part of the syllabus, but if you want to learn more, once you're done and you want to do fractional calculus with me or other colleagues for research, then you can come. You're more than welcome to do so.
Will do.
Yes. So now let's look at this. It's very important that you see very carefully when to use which identity. Now look at here. They say if n is an even number and you're integrating sine, it's important to note you're integrating sine and you see that sine is an even number, then you use this identity over here. Are we all together?
Yes.
Which color do you want today?
What's that gold color? How does it look like? I'm curious.
Okay. I'm not sure if gold will. This is how it looks.
It looks ugly. I take it back.
Guys, what color?
Green. Pink, ma'am.
Pink. Do you agree with pink? We did use green last time, so we'll use pink. If you don't say any color, I'll choose white and I'll keep on writing. So
Pink.
let's look at this. Now, do you see that? Can you see that this is the integral of, maybe I should enlarge a little bit. Is it clear?
Yes, ma'am.
Yes, ma'am.
Now, do you see that n is even here? It's a 2
Yes.
there. So since it's n is even, then what you do, you say this is equals to the integral. You use this identity here, right? So then this is equals to 1 over 2, 1 minus cos of 2x dx. Now, then you can multiply inside, right? So then this is half multiplied by 1. So this is the integral of 1 over 2 minus 1 over 2 cos of 2x dx. Now, remember we said we can separate the integral, right? And then say integral of 1 over 2. So this is equals to, dx minus the integral of, let's put 1 over 2 outside, cos of 2x dx. Do you see that? Now, let's go back. Can we integrate the first part? What is the integral of this?
0.
The integral, not the derivative.
Is half x.
Half x. Well done. Do you understand why is it half x, guys?
Yes, because if we do the
Yes,
reverse,
ma'am.
it will give us half.
Okay. Is there a person who doesn't understand why we got half x? Okay.
Can you please explain, ma'am?
Okay. Now remember, remember with integrals, right? You can take out the constant outside the integral sign, right? Now, if you write it, okay, let's choose this color over here. Let's write it here. If you can take out the integral. So this is half dx, right? Now you take it out the half. Do you agree that inside here will remain with 1 if we take out the half? Hello?
Yes, ma'am.
Thank you. So then this is 1 over 2 integral of x to the power of 0. Do you agree that x to the power of 0 is the same as 1?
Yes, ma'am.
Yes.
Thank you. So then this is equals to 1 over 2. And remember we said if we have x to the power of n, let's go back. If we have x to the power of n, then it will be n plus 1 over n plus 1. So meaning that this will be x to the power of 0 plus 1 over 0 plus 1. So then this plus c. So then this becomes 1 over 2x, which is this one over here. Oh, we haven't written it, which is 1 over 2x. So meaning that when you differentiate, what's this? When you integrate a constant, it will come with the whatever variable that you are integrating with. Because here it's x, so therefore, because this is a constant, this will be 1 over 2x. Are we together?
Yes, ma'am. Yes, ma'am.
Thank you. Now let's integrate this one. How do I integrate this one? What is the answer there if I integrate it? What is the answer? What did you differentiate to get cos 2x?
Sine 2x.
Sine 2x. Let's go here. So we have what? We have, under here we have cos 2x, right? Look at this. This is what we have. So we have the integral of cos of 2x, right? Dx. Now we cannot say it's sine x, sine 2x. Why? Look at, if we write here, this is sine of 2x plus c. If we differentiate sine 2x, do you agree that we end up with 2 times cos of 2x? Do you see that, guys?
Yes,
Hmm?
ma'am. Yes,
Yeah.
ma'am.
So this is not this, isn't it?
Yes.
So meaning that it's only this part. And from what we have learned last week, we only needed 2 here so that we can write it as and use this formula of over here. So we said that for us to introduce a 2, what do we do? We multiply by?
Multiply by 2 over 2.
Thank you. 2 over 2. So meaning that we come here and say 1 over 2, integral of 2 over 2, cos of 2x dx. Because we want a 2, we can actually take out what? A half. So this is 1 over 2x minus 1 over 2 times this 1 over 2, integral of 2 cos of 2x dx. Therefore, after this, we can now then multiply, we can then now write this as sine 2x. So this is equals to 1 over 2x minus 1 over 4 sine of 2x plus c. Did that make sense?
Yes, ma'am.
I need 3 yeses.
Oh, yes, ma'am.
One more yes. If there's a
Yes,
no,
ma'am.
it cancels the whole thing. Good. And there we go. That's the answer. Now let's look at this one. What do you think will happen here? What do you think this will happen here?
It's also even, ma'am, so do not use the same approach.
Okay. So let's paste there. Yo, where did it paste? Okay. They said that if n is even, we use this identity over here. Sharp. So let's see. We have, where did it paste? Okay, let me just paste that here. There we go. So we have this. Where do I start? Remember that the identity says sine squared x is equals to 1 over 2, 1 minus cos of 2x dx. So where do I start? I have to the power of 4. So what do I do? Help
You
me.
use 1 over 4.
No.
No, you're going to say integral of sine squared x into bracket sine squared x dx. Then you take it from there.
Thank you. Does it make sense? Did we lose anyone?
Repeat that again?
So you say that, remember that sine sine to the power of 4x dx can be written as integral of sine squared x squared dx. Then this sine squared is this one over here.
Oh, okay. So it's just everything squared.
Yes.
Okay.
Or it can be written as integral of sine squared x times sine squared x dx, which means that we can apply this identity because here it's sine squared and here it's sine squared. So let's apply that identity. So this is the integral of 1 over 2, open bracket 1 minus cos of 2x 1 times 1 over 2, open bracket 1 minus cos 2x, close bracket dx. Now, do we agree that this, we can times this and take it outside the bracket?
Yes.
Yes, ma'am.
Thank you. So this is equals to 1 over 4. 1 over 4. Okay, what's going on with the pen now? Sorry about it. 1 over... Okay, let me take another pen. So this is 1 over 4. The integral of 1 minus cos of 2x, open bracket 1 minus cos of 2x. So we're doing it like this because in the study guide, they started here. So I'm just showing you how to do it in another way. So then we know that this is equals to 1 over 4, the integral of 1 minus 2 cos of 2x plus cos squared 2x dx. Are we all together there?
Yes,
Am
ma'am.
I right?
Yes, ma'am.
Yes, you're right.
Thank you. Now, let's separate the terms, right? Take the integral of the individual terms. Now, you should be very careful when you're separating the integral, the terms, and giving it its own integral. Remember, there's a 1/4 here. So meaning that when you start, it always should be 1/4 integral of 1 dx minus 1/4 integral of 2 cos 2x dx plus 1/4 integral cos squared 2x dx. Are we all together?
Yes.
Yes, ma'am.
Thank you. Now, by looking at this, do you know the integral of that?
Yes, ma'am.
Which is?
1/4x.
Thank you. So it's 1/4x. Do you know the integral of this by looking at it?
Yes, ma'am.
What is the integral of that?
It's minus plus 1/4 sine 2x.
Well done. Do you know the integral of this?
Yeah.
So I'm assuming the yo means I don't know.
I'm still figuring it out, ma'am.
So let's go back to the standard table. Let's go back to the standard table. Do you see any integral of the power here? Let's go back. Let's go back. Where's that page? Do you see any integral of power of sine here? Or cos? You don't see any, ne?
Yes, ma'am, we don't.
So it means that we need to use an identity to simplify our work. So which identity will help us? This one over here. Do you see that?
Yes, ma'am.
Yes, ma'am.
So then this, okay, so we have cos 2x. So this will be what? Please help me. So we said this is 1/4x minus 1/4. We know that this is sine 2x, sine 2x plus 1/4 integral. Now let's replace with this with identity. So it'll be 1/2, open bracket,
1 plus
1 plus
cos 2x.
Cos 2x.
cos
2x, ma'am.
2x.
cos
Yeah.
Right.
Remember, initially we had, okay, remember we had, this is what we had, cos squared x is equals to 1/2, 1 plus cos 2x. Now we have cos squared 2x. So this will be 1/2, 1 plus what? Cos.
Cos 2x. Wait. No. Will not be.
Here it
Or-
says where you see x, put 2x. Here it says where you see x, put what?
2x.
So this will be what?
4x. 4x.
Thank you. 4x. Are we all together? Thank you. So meaning that this over here will be 4x dx. Now this, we're just writing step by step, guys. You don't have to write all these steps. The reason why we are writing all these steps, we just want to see properly what's going on. So this becomes 1 times, this becomes 1/8. Do we agree?
Yes, ma'am.
Yes.
The integral of 1 dx plus 1/8, the integral of cos of 4x dx. Now, can you integrate this?
Yes, ma'am.
What is the integral of that?
1/8x.
Number 8x.
Thank you. So this is plus 1/8x. Can you integrate this?
Yes.
What is the answer then, since you said yes?
It's gonna be 1/8 times 1/4 sine 4x.
Well done.
it-
Did you see what she did there?
Yeah.
So we
Thank
divide
you.
4. We introduce 4/4.
Thank you. Well done. So meaning here we have to introduce 4/4 and we take out the 1/4. The 1/4 will times by 8. What is it, 32 or 36? 32, ne?
Yeah,
And then
32,
we remain with 4 cos of 4x dx. Then it means now this becomes what? This becomes sine of 4x, right? So the entire thing becomes 1/4 minus, okay, but then, sorry, there's a 1/4x here and a 1/8 here. What is the answer there?
1/4.
Guys,
Oh, yeah.
you are
Sorry
used to
about that.
calculators, ne?
Yeah.
Yeah. Okay, sine 2x plus 1/32 sine 4x plus c. Is it clear? So you don't have to do all these steps that I've done, guys. We're just doing it because we want everything to be simplified. Are we all together? Yes or no? Did I miss anyone?
Yes, ma'am.
Yes, ma'am.
On the same boat.
Alrighty. Now they say, what happens if n is odd? Meaning that it has an integer power, but then when you divide the power, what happens? When a number is odd, you have a remainder. So meaning that it can be a 3, 5, 7, 11, whatsoever, 13. So when n is an odd number, we make use of the following identities. Do you see the identity that you use? Don't get
Yes, ma'am.
confused. Eh? Don't get confused. Look at here. Okay, let me just copy this. Look at here where the power sine squared, they replaced with 1 minus cos squared. They didn't replace with a half 1 minus cos 2x. Do you see the difference?
Yes.
Why did they do that?
It's because when
It's
they
the
split
odd
it,
number.
right?
Mhm.
Yes, number one, n is odd number. So meaning that every time when n is odd number here, without splitting, you use this. Right? Even if you split it, like as long as they say n is an odd number and you have sine to the power of n and n is an odd number, you use this. But when n is when n is an even number, you use that.
Even, yes.
Yes. Now when n is an odd number, you first split, there will be a part where it's even and there will be a part where it's odd. Are we together?
So, ma'am, on the even part, why don't we apply the first rule of the identity?
On the what?
Isn't it we split the odd number? So when we split it, we're gonna get an even number and a 1, right? So why don't we apply the rule of an even number on the first split number? For
It's
instance, we have,
because
yeah,
if oh sorry, continue with your question.
I think you grasped my question.
Okay,
Because
it is
it's
because once you use the rule of this, you'll confuse yourself more. It actually will confuse you more. You know why? It's because here there's a 2x. Do you see that? And now you'll end up having the odd one, which has sine x, and now the even one, which the odd one that has an x and the even one that has an 2x. So how are you going to deal with that? Because then you'll end up have to go and use double angle identities for you to simplify the work again, so that you only have sine of x or cos of x and not have cos 2x and cos x. Does it make sense?
So, ma'am, that brings up a follow-up question. Does this give us this? Can you prove this equals to cos 2x?
Which one?
The new identity we're using compared to the previous one in terms of even.
We can try it after class.
Okay.
We
Because I
can
also
try
want
it
to
after class, but let's see. You're saying we should use that other identity. So we have
Yeah.
1 over 2. Konje, what is it? 1 minus cos of 2x,
Yeah.
right? Sine of x. Ne?
Mm.
Now, it means that we need to look for an identity for this one over here. So what can that identity be?
Uh,
Do you remember your double angles identities?
if it's for cos 2x, what is it?
Because we don't want, the reason why we are using this identity because of the x here as well. We don't want to have a 2x here and an x there. Because then otherwise you'll have to go and simplify this.
Oh,
Do you
wait.
see that?
Yeah, I see it now.
And now, if you look at this, there's also, let's remember the identities of cos. Let's check, did they mention them here? Of double angles, sorry. The identities of double angles. Okay, they're not sure. There's only one here. If you derive it, there's only one. Can you please remind me the identities of double angle? I think we have cos squared x minus sine squared x, isn't it?
Yeah, we also have sine double angles. Was it sine 2x equal to 2 sine x and cos x?
Yes, but we want the ones for what's this? We want the ones for cos only. Yes.
For 2x, was it not cos 2x minus sine squared x?
Please check.
Let me check.
Please check. So this is 1 minus cos of 2x sine of x. So meaning that you will then have to go and find the identity. So we have cos squared x minus sine squared x. What are the identities there?
Yeah, it is. It is cos squared x minus sine squared x.
And then the other one?
And the other one is which one, ma'am?
For
Oh, you just
cos
mean
2x. Yes.
it's also 2 cos
Sine
squared x minus 1.
And then the other one?
The other one is 1 minus 2 sine squared x.
2 sine squared x. Now let's look at this. Right? It means that here you'll have to simplify. Let's choose 1 and see what happens. So if you have 1 over 2, if you choose 1, let's choose maybe this one over here. So this will be minus 1 minus, sorry, minus 1. Am I substituting properly? It's 1 minus 2 sine squared x times sine x. Do you see that? So then this is equals to 1 over 2. Now 1 minus 1 is what?
0.
It's 0. And then this becomes what? Positive 2 sine squared x times sine of x. Do you see that?
Wait, what
Then
happened to the
this is
minus?
equals to,
What happened to the minus?
it times, this minus times the
minus and
minus
minus.
outside.
Oh, I see. Okay.
And then this 2 times that 2. So then we have sine squared x times sine x. So meaning that the identity that you'll use here, again, you can't go back to this one because you see it takes you back to sine x. So meaning that the identity that you need to use that is much better is 1 minus cos squared x times sine x.
Oh, okay.
Yeah. So that is why it's important that once you split, you use what? These identities that are here. Instead of using the ones that are double, because the double part will take you back to sine squared x and cos sine squared x and sine x.
Oh, okay.
Thank you.
I think it's still the same thing because if you use the second identity,
Do you see that? It will give you cos. Then you have to still use 1 minus, what's this? You have to use 1 minus something again. So that's why they're saying stick to these identities here. So it means that when you have even, the identity that should be in your mind is sine squared x plus, when you have odd, cos squared x is equals to 1. Are we all together there?
Yes, ma'am.
Yes. Thank you. Okay. There we go. So I think they were integrating. Please mute. So remember, when it's odd, we split squared x times sine x dx. Then we use the identity sine squared x plus cos squared x is equals to 1. So we have sine what? We have sine squared. So this means it will be sine squared x is equals to 1 minus cos squared x. So we go and substitute. So this will be integral of 1 minus cos squared x times sine of x dx. Now let's multiply inside. This one will be the integral of sine of x dx minus the integral of cos squared x dx. Can you integrate the first one?
Yes, ma'am.
Yes.
Can you integrate the second one? What's the first one? Let's put the answer for the first one.
It's minus cos x.
Do you understand why it's minus cos x, guys?
Yes.
Yes.
Thank you. So it's minus cos of x. Now, can we integrate this one over here?
Yes, ma'am, we can.
What is the answer? What is the answer? What is the answer?
Okay, we are still doing it.
How are you doing it? I want to know. I need to know how are you guys doing it? Because me, by looking at it, I don't know how to do it.
Which means we will introduce that half 1 plus cos 2x.
Thank you. Because n is even here. So we go and check the identity for n even. It's here. There we go. It's here. So this is what? Let's put half outside, or let's just write it. Integral of 1 over 2, 1 plus cos of 2x dx. Is it 1 plus, ne?
1 plus, yes.
Yeah, it's 1
So
plus,
this
ma'am.
becomes minus cos of x minus 1 over 2 integral of 1 dx minus 1 over 2 integral of cos of 2x dx. Can we integrate this one?
Yes.
Yes.
Can we integrate this one?
That one to be 1 over 4.
Thank you. So we need to integrate a 2 over 2. Add in a 2 over 2 there.
Yeah,
So then this is equals to minus cos of x minus 1 over 2x minus 1 over 4 sine of 2x plus c. Are we happy?
Yes.
Yeah.
Huh?
Yes.
Yeah.
Are you sure we are right?
Right.
Now we're right, man.
Yeah. Makes sense. Just applying the same methodology. Okay, so
Something is wrong here.
wait.
And I continued because you guys don't see. Can someone tell me where I'm wrong?
Not 2 sine x.
I think that negative should negative be positive 1/4.
Yeah. Well, yeah. What's going on here? How did we multiply this times that? It's sine x, isn't it?
Yeah,
This
it needs to be
times that.
yeah, cos squared x sine x.
Thank you. So this part, it's wrong.
Yes.
So let's rewrite it. I'll write it fast. So this is integral of sine to the power of 3x dx. So make sure you don't make such mistakes. So sine squared x, sine of what? X dx. Remember we said we split and then we take the one that is positive, we use the identity, this one over here. So then this will be equals to the integral of 1 minus cos squared x sine of x dx. Let's multiply together now. We say 1 times sine x. So this
Sine x.
is integral of sine of x, right? And then we say sine x times this. Then this becomes minus cos squared x sine of x dx.
So
Are we
wait,
all
ma'am,
on the same
so
page?
we separated it just to multiply back into it.
Yes, we didn't multiply the sine back to it. We only said cos, the integral of cos x. That's where the error was. So we didn't multiply the sine x with the cos x. So then this is then gives us integral of sine of x dx minus the integral of cos squared x sine of x dx. Now, can we integrate this? We agreed that this is what? Before it was negative, positive, so it was minus cos of x. Because if we differentiate negative cos x, we get what? Positive sine x, which is this one. Here, what do we do now?
Yeah.
Don't say no.
Can we split it again, or we have to
No.
differentiate as a whole?
We're not splitting anything.
Can use substitution.
What substitution?
Like you can let
power.
you can let u because you can let u because to cos x, and then you let what do you call it, du equals to integrate that cos x.
You can't use substitution.
Okay.
Oh.
It has
What about this?
squared.
Wait, there's a lady
So we use
talking here.
it has a power, so we use n+1
Why?
for cos squared,
Okay, why?
because that's how we integrate
Guys,
power.
this is you forgot this. This one over here. It's a function with a power, which is cos squared x, where n is 2. What is the derivative of cos? Negative sine x, isn't
Negative
it?
sine.
Sine x. So you have this. You're just missing this. So therefore, it means you can use that. Do you see that?
Yes.
Well done. So let's go back. So meaning that we're missing what? We're missing a negative. So it's -1 over -1. We now know by now. So this will become what? Positive, isn't it? Because we're introducing a negative. Let me do it step by step. -1 over -1. This negative then multiplies. This one becomes positive. Then integral of negative cos squared x times. Okay, let me write it like this. Negative. Sorry. Yay, what's going on? So this becomes negative sine of x times cos squared x dx. And we know that we have a function, its derivative is this, the power. So meaning that we'll use this as negative cos of x plus cos to the power of 3x over 3 plus c. Did I lose anyone there?
Oh,
Yeah, and then you applied to the power of n plus 1 divided by n plus 1. Don't think I don't understand this. Wait, go back. How did you confirm that it was that previous function when you reverse derived?
How do I confirm where?
Before, when before you confirmed cos squared, like what's the integration of that?
Yeah.
Yeah.
Remember, there's a rule that we learned last week that if you have a function, f to the power of n, f of x, times the derivative of that function, dx, then this is equals to f of x n plus 1 over n plus 1 plus c. Now,
Yeah.
in this case, we have the integral of cos squared x sine squared x, sine x, right? Dx. Now, I looked at this two first. I'm like, this side function is a power. So if I take this function to be f of x, let me write it here, to be f of x, which will be what? Sine of x, isn't it? Now, what is the derivative of sine of x?
It's cos.
Sorry, not the function. The function, this function is cos of x, right?
Yeah.
Cos of x. What is the derivative of cos of x equals to?
negative sign.
Negative
sine x. So meaning that I do have this part. Yeah, but I just need the negative. And from what we have learned, I can introduce the negative.
Oh, okay.
Yes, so meaning that this is then equals to what? Negative cos to the power of 3x over 3 plus c. Now, because there was a negative on top here, negative times this negative, they become positive. That's why we ended up here.
Oh, I see, man.
Okay. Let's move forward. We're here. Okay. Let's look at cos. But we saw Musuwuti. Okay, we did integrate this one, cos squared 2x, isn't it? So I can skip it, ne? Guys.
Wait,
Yes, we did that one. We did,
did
yes.
that. Wait, why did they give us an example if we already did it? What is the purpose of adding that?
It was just important to remind you.
Oh, okay.
Yes.
Yeah, we can skip it.
Yeah, so that when your exam is Monday and some of you have papalas, you can easily remember. Because you don't put
Black
it,
label the day before.
of course. So you guys have to remember. Now let's look at n. Do you see that when you have n both for both functions, do you see for cos and sine, when you have n odd, you split, one will be made, what's this? One will be made even and the other one will be made odd. The even one, you replace it with the identity 1 minus sine squared or x or 1 minus cos squared x. Are we together in this boat?
Yes, ma'am. So wait, what I'm understanding this is it's basically similar to the even, just that we're making sure that the other function is always an even.
Yes. So it's just the same rule as the cos, sine even, but here instead of using 1 minus cos squared, you'll use 1 minus sine squared because you're dealing with cos.
Okay.
So let's look at this. So meaning that the important identity is always sine squared x plus cos squared x is equals to number uno. Now let's split. So this becomes integral of cos squared x times sine, why am I saying sine? Times cos of x dx. Now use this identity. So this is the integral of 1 minus sine squared x cos of x dx. Remember, multiply this by that. So this is equals the integral of cos of x. multiply this by that, this becomes minus sine squared x cos x dx. Now you can integrate from here, but from here and give the answer. But remember I said we will do it step by step so that we all understand it properly. So let's separate the integral sign. So this is cos of x dx minus the integral of what? Sine squared x times cos of x dx. Can we integrate the first one?
Yes, ma'am.
What is the
Yes.
answer?
It's sin x.
Minus sin x.
Sin
Thank
x.
you. Sine x. Minus, can we integrate the second one?
Yes, ma'am, we can.
Which rule are we using?
Exponent.
The one we were using in our previous question, or
Thank you.
previous example.
Thank you. Because we can see that our function here is what? Is sine x. Ne?
Sin x.
Our n is what? Is 2. And our derivative here is what? Is cos of x. So meaning that we can say this is what? Sine of x to the power of 3 over 3 plus c. So this is sine of x minus sine cube of x over 3 plus c. Are we happy?
Yes.
Thank you. Then you go and do those ones. Okay, let's look at this one over here. And remember in the exam, I won't say when n is even, when n is odd. You need to know. You need to know. I'll give you the identities when you just need to know when to apply which one.
All of them, ma'am. Even the double angles, you're gonna give it to us.
I'll have to look at the, what's this? Not all of them, all of them. I'll have to look at your formula sheet for the exam again.
Okay.
Because I'm assuming that, and don't rely on, what's this? Don't rely on your formula sheet and say, oh no, in the exam, I'll look at the formula sheet. Try to memorize them. So meaning that do practice to a point where you memorize them so that you can be able to do what? You can be able to apply it properly. Because if you memorize them and you have, if you don't know them, you have to go and page back, page again, and whatsoever to write your exam. You're wasting your time. So let's look at when either, meaning that either m or n is an odd number. We split the odd power and use the identity sine squared x plus cos squared plus 1. Did you hear what they said?
But
Yeah, macro.
Did you hear what they said, guys?
so we split the
Yes.
odd. Okay.
Yes. So meaning that you look at which one are we going to split, the sine or the cos?
The sign.
Thank you. The sine, because it's the one that has the odd power. So let's split that. So this will be equals to the integral of sine squared x times sine of x cos squared x dx. And then use the identity. Where do I use the identity?
On the sin squared
Take
x.
sign out, man.
Did they say use it on the sine squared?
Sin square x plus cos square x, it will be equal to 1. So you take sin x out.
I understand, but did they say replace on the sine squared x?
Aren't we just
No, they
trying to
didn't.
replicate their identity? That's why we took it out.
I understand, but then they said when either m or n is odd, is an odd number, we split the odd power and use the identity way.
The whole expression there, which means that we'll replace the whole expression with that sine square plus cos square x plus is equals to 1.
So meaning we replace this one and then replace this one again.
Where it's applicable.
It's applicable here and it's applicable here. So where do we replace exactly?
The odd.
We can't
Odd.
replace the identity because there's no squared here. So this one, leave it alone.
So does that mean then we leave it as it is?
With sine here, you leave it as it is. My question is, do you replace here or do you replace here? Do they mention which one you replace? Because this one can use an identity and this one can use an identity. So you replace the sign.
Yes, ma'am.
Yes, ma'am. In your study guide, they replaced with what? With what? They replaced the sign in your study guide. Guys. So they replaced the sign, eh?
Yes.
Let's see
Yes,
what
ma'am.
happens
Yes,
if we
ma'am.
replace cos. Let's see what happens if instead we replace cos. So we say this is the integral of sine squared x times sine of x times cos. Let's make it 1 minus sine squared of x dx. Right?
Yes.
Now this becomes integral of sine squared x times sine of x dx minus, please mute, integral of sine to the power of 4x times sine of x dx. So then this becomes integral of sine to the power of 3 of x dx minus integral of sine to the power of 5x dx. Right? Now, do we know sine to the power of 3? Guys,
What do
do
you
we
mean
know sine to
we
the
know?
power of 3?
I think we solved it up there.
Yeah, we solved it. Do you see that?
Hmm.
So meaning that this becomes negative. What was it, guys? Please remind me. Let me
It's
see
cos
this.
x minus cos x
Negative
minus cos x.
minus cos x
Yes, ma'am.
minus cos of x.
Then it's plus cos cubed x over 3.
Over 3. Minus, I know we didn't solve this, but it's in the post test. Can you go and give me the answer in it? What is the answer in the post test? Guys, are you checking it?
The answer is negative cos 3, cos squared 3, I mean cos 3, cos to the power 3x over 3 plus cos 5x over 5 plus c.
Plus c.
Mhm.
Plus c. Right?
But
Now let's see.
that is the whole answer, not excluding the negative cos x plus this one 3.
So you're saying that we are looking for the integral of sine to the power of 5. Is it negative cos to the power of 3x over 3 plus cos to the power of 5x over 5? Is that what you're saying?
Yeah,
Guys, it's in the it's here in the post test. Look at it. Sine to the power of 5. Where's the solutions to the post test? Let's go back to the solution to the post test. Here it is. Do you see that? Sine to the power of 5, it's negative cos plus 2 cos to the power of 3. Let me see which page is this. Which page is this now? Okay, I found it. Let's write it. Okay. So we know this one, the first one. We did it. It was here. It's this one over here, right? No, it's not this. The integral of sine to the power of 3, where is it? It's this one over here. Negative cos of x plus cos cubed over 3. So negative cos of x plus cos cubed x over 3, right? We covered this one. Minus this one on page 22. The answer is on page 22. The
It's
post-test.
negative cos.
Yes, please give me. It's negative
Negative cos x.
cos x.
Then it's plus 2 cos cubed x
Over.
over 3. Then plus cos.
Is it plus or minus?
Minus.
It's minus, yeah, cos 5x, yeah, divided by 5.
Plus c. Okay. So now let's simplify. Do you agree that this one will cancel that one?
Yes, ma'am.
Yes.
So then this is equals to, look at this one and that one. What do I get the answer to be?
It will be 0, also 0. So,
0, how would it be 0?
It's 2, right? 2.
This is, it will be?
It will be
Cos cubed x.
cos to the power 6x. Eh?
Why cos to the power of 6x?
No, are we not multiplying this? Oh, okay. No, no, I get it. No, sorry.
Thank you. And then, what is this plus?
Plus cos
to the power 5x over 5.
Plus c. Now let's see if it's exactly the same answer as what they got. Which one are we doing? There we go. Do you see that?
Yes, ma'am.
So they didn't mention which one we replace. So meaning that, let's say, please mute, meaning that, let's say, instead of replacing this one with an identity, you replace this one with an identity. But this one was going to take you longer. The one we did here was going to take you longer. Do you agree with that?
Yes, ma'am.
Why is that?
It's because you were supposed to go and integrate sine what's the sine to the power of 3x, which is a long step, because there we just took the solutions. Do you see that? And then you go and integrate sine to the power of 5x, which is also a long step before you get to the solution. Meaning that it matters which one you choose, basically, to replace. And this one, it's just easy because you can see that this will be a function, which is f of x, cos of x, the derivative of a function, which is sine of x, and the powers. Here the power is n is 2, and here is the power is 3. So meaning that for the same problem, someone can get 1, 2, 3 steps, and someone can do more than the steps. Are we all together? But at the end of the day, you will end up in having the same solution. Yes.
So, ma'am, I just want to understand, is it possible if we can just skip the steps? Like maybe I'm writing my exam, then I skip all those steps and just say sine cube x is equal to, then I just write the solution. Is it allowed?
You mean like the way we did here?
Yes, ma'am.
No, it's not allowed. You have to write all your steps. In the exam, I'll assume you don't know. Isn't that we went and copied the solution for integral of sine to the power of 3x?
Okay, what if maybe there's a similar question up there? Do I have to redo it again?
No, if there's a similar question where you did it and you found the answer, then you can substitute. You don't have to go and do it again. You look at, guys, you look at your marks. Look at the marks that you're given. If you are given 2 marks, you can't go and do 20 million steps for 2 marks. Is that
Okay,
clear?
ma'am. How do you discern which one to use?
Normally, what happened is you'll see as soon as you simplify. For example, with me, I saw here, as soon as I got here, I knew that I'm in trouble. because then I have to do the what's this sine to the power of 3x, which is this whole part. Sorry, why am I highlighting the wrong thing? Sine to the power of 3x, which is this whole part here, and then sine to the power of what, 5x, which is something that is page 22, which is this whole part here. Then you can see, I'm in trouble. Let me substitute with the other one. Because if you try the other one, right, then you'll notice that it will be the integral of sine to the power of 3x cos squared x dx. Now, remember they say split the odd and then use the identity. So sine squared x times sine of x cos of squared x. Now dx. Now if I replace with sine, look at how easy it becomes. So this becomes, if I replace this one instead of this one, so then this becomes 1 minus cos squared x, right? Sine of x times cos squared of x dx. So then this becomes the integral of sine x times cos squared x dx minus integral of what? Of cos to the power of 4x sine of x dx. And from this point, right? From this point, I can see, okay, fine, here, because there's a power and there's a derivative. So my function is what? My function here is what? Is f of x. And even here, my function is f of x. So my function is f of x, which is, cos of x. And then the derivative of f of x, I know it's minus sine x. So meaning that I'll just introduce a negative here, integral negative sine of x cos to the power squared x dx. Even introduce a negative, this becomes positive, integral minus cos to the power of 4x sine of x dx. So therefore I just use the rule. So this is equals to minus cos to the power of 3x over what? Over 3 plus cos to the power of 5x over 5 plus c. Do you see that? So this is only a few steps compared to this one over here. So sometimes when you replace and you see that it's giving me a problem, replace the other one and see if it won't be easy for you to solve. Are we together?
Yeah, we are together, but my worry is that statement, man, for me, it doesn't suit me well. Just go to it again, that one with the M.
This one?
Yes, this one, yes. Because now they said when either M or M is an odd number, we split the odd power and
So when either M or N, so meaning that M can be odd, M can be what? Or M can be, or both can be odd. So then split.
Yes.
And make it even, and then use the identity. Now, if both are odd, then you split. So if both are odd, it means that you're going to split one, right? Make it an identity. The one that is, make it even. The one that is even, then replace it.
Yes.
Does it make sense now?
Yeah, it makes sense, but I'm worried about this statement because they were just supposed to say we split the odd number and use the identities, not to use like they put sine squared x plus cos x squared is equals to 1. We think maybe we have to change the whole expression and put this side. But now the way you explain it, I followed 100%.
Okay, no, that's good. That's good. So I hope I haven't lost anyone, ne?
You lost me a little bit, ma'am. So just to clarify, so how do I know which expression to use?
So as I said, sometimes when you're solving, right, you will notice that, look at this one. That one I did it first. You will notice that this, I have to integrate this and I have to integrate this. And because I've done I'm assuming I've practiced the post-test of this question, right? In code, I've practiced. I've never practiced them. But I've practiced the questions in code, right? So then I know the answer. That's why I substituted. But then if you replaced this one takes you longer than replacing the one that you have splitted. Remember, we split the sign. One was
Yeah.
even and one was odd. Then we replaces the even sign of it. That's why it made this easier.
So basically the word on that thing is very misleading.
It's not misleading. It's not. Because you can replace both of them. I mean, you can replace one of them. You can either replace the, what if this one was this? What if this one was odd? It means you still have to use this identity. That's what I'm saying. So it's not misleading. Here, I was just making an example. Look at here, there's a 2 and a squared. And look at here, there's a squared as well. There's a squared. So it means that you can either replace this one or that one. But one will give you a lot of steps compared to the other one.
Oh, I see.
Yes.
Okay.
I think we're done. Eh? Yo, we're not. Yeah.
No, man, we know.
We have a lot, man. A lot. We're not even halfway.
Okay. So let's look at this one. When M and N, guys, you need to be very careful with the wording. Me and you. So remember the N and the O, right? Do you remember it? If I say me or you are going to the mall, is that the right English? Yeah, me and you. Me or you going to the mall. What do I mean?
Does it not mean
Either
we?
or.
That's okay.
Simple English.
Either or. Any will
Simple
do.
English. Tell it to a 5-year-old. Crash. What would you say?
Together?
It's either one goes and the other stays.
And me.
Something is
With
missing.
and we both going. Me and
Yeah, and means both. So
guys, can someone tell me or you? What
okay,
does it
or
mean?
means either one. So wait. So we have to simplify that. Isn't it like you?
So if I put it in the exam, you guys will be sorted, ne?
Hey, wait, hold on. Let's not move. Let's understand each other. So when you say me or you,
Yeah.
it means one.
Google, what does or mean?
addition. Addition.
So you're going to, if you tell a 5-year-old and say, if I say me or you
okay.
going to the mall, you're going to say it means addition
Or
mall.
means me or you. Either one stays, the other goes, or vice versa.
I simplified, my man. This is a
Something is
5-year-old.
missing. Something is missing.
Between me and you, and one of us will go to the mall.
I leave it for the exam.
With and, with and is guaranteed that we both are going to the mall. You and
Yes.
I are going to the mall.
Definitely.
Okay.
When are we going?
It's not specified when, but we definitely
I
going
said
together.
when. You said me and you. You said me and you we are going to the mall. When are we going to the mall?
Today.
Are you sure? I'm in the office. Okay, guys. Go and fix when either M or N is odd. I'll skip it. So when M and N are even, it means me and you are washing the dishes, are going to the mall. So meaning that both of them are even. They might not be the same even, meaning that one can be 8, one can be 2, but both of them are even. It does not matter which function is replaced by an identity, period. Does it make sense?
Yes.
Thank you. So let's see which function they replace with an identity in the study guide so that we use a different one. because they say it doesn't matter. So meaning at the end of the day, we'll have to get the same answer. So they replaced with what? They replaced
Sine.
sine. Let's replace with cos. Let's replace the cos because they replaced the sine. So since they replaced the sine, which identity they mean? Do you remember the identity that they mean? They are talking about sine
The
squared
sine
x plus cos squared x equals to 1. So meaning that they replace sine, we're replacing cos. So sine squared x times cos squared x dx is equals to integral of sine squared x times 1 minus, ne? 1 minus sine squared x dx.
Yes.
Now this is equals to the integral of sine squared x dx minus the integral of sine to the power of 4x dx. Are we all together? Do we know this?
Yes.
Okay, let's
we
go and
solved
find
it.
it. We did find
So
it, isn't it?
it's half minus half into 1 minus cos x. I mean sine x.
It's this one over here. We found it. It was here, right? So this is what? Equals to 1 over 2x. I'm waiting. I'm listening. Guys, 1 over 2x minus 1 over 4x sine 2x minus 1 over 4 sine of 2x, right? Are we together, guys?
Yes, ma'am.
Yeah, because this is the integral of. Now, minus the integral of sine to the power of 4x, this integral. Where is it? Did we find it? Let me see.
Yes.
Yes, we found it on page 15. It's here. It's this long one here. So this is the answer. Right, let's go and substitute it. So this is what? Minus, so remember this whole thing, you need to put it in bracket, minus 3 over 8x minus 1 over 4 sine 2x plus 1 over 32 sine of 4x plus c. So now this minus 3x minus 1 over 2x minus 3 over 8x. What is the answer?
It's 1 over 8 x.
Positive or negative?
It's the positive. Positive.
Well done. Do you see that this is negative times negative? This becomes positive. So meaning that this cancels this one, right? That's 0.
Yes,
And then this time, so it's minus 1 over 3, 2 sine of what? What is this? Sine 2x? Sine 4x, sorry. Sine 4x plus c. And if you go and check, you'll see that you find the same answers as the same as if you have replaced with what's this? You have replaced with cos. So meaning here it might not make sense what they did, but here they went and found the integral of cos, which is this one, and then they went and find the integral of cos to the power 4 with which is that one, and then you need to do the subtraction and get the final answer. Are we together?
Hey,
Yes,
for the
ma'am.
most part,
Can
man,
you
this
go
is a
back to the
very
answer?
long step.
Your answer.
Yeah, it is long step.
Can you go back to your answer?
Ma'am.
Did I miss something?
With this one, it's 1 over 8 with yours. And
Yes.
on the example is 3 over 8.
It's not 3 over 8.
There.
It's not 3 over 8.
There it is,
What?
3 over 8x.
What is the 3 over 8 for?
I'm not sure.
It's for the cos 4x, cos to the power 4x.
Yes. So
Which one?
remember they splitted. This becomes what? The integral of cos squared x dx minus the integral of what? Cos to the power 4x dx. Do you see that? Now they went and calculated this part over here, which is this one over here. And they went and calculated this part over here, which is this one over there. This one over here. And then when you subtract them, let's subtract the 2. If you subtract 1 over 2x minus 3 over 8x, do you see that you get 1 over 8x? This over here, subtract that over here, they cancel each other. Minus this one, so it's minus 1 over 32 sine 4x plus c. So it's the same as ours, regardless of which identity we replaced. Makes sense?
Okay.
Good. Hey, we're not done. So let's look at the integrations where you have sine ax, sine bx, sine ax, sine bx. What am I saying? Sine ax cos bx, sine ax sine bx, and cos ax cos bx. So they say that if you have something like this, these are the what's this identities you are going to use. Do you see that? Look at the identities, guys. So let's take an example. Okay. Take a screenshot. Come on, come on, come on, come on. Come on, come on, come on, come on. Okay. There we go. Now, which one are we using? Number 1, 2, 3, or 4 on example 8? Which one are we using?
Oh, number 1.
Number 1.
Thank you.
Why?
Number 1. Do you see that? Because it's sine x cos y. So then this is equals to the integral of 1 over 2. What is x? X is equals to 3. Y is equals to 5. Do you see that?
Yes.
So then the answer is sine of 3 plus 5 plus sine of 3 minus 5. Sorry, what am I saying?
Put
Sorry.
X there. Put X.
Yeah,
Always the
yeah.
X's.
I'm democrat. So let's put x's. That's what I'm saying. What am I doing? So it's 2 2, so that's sine of 3x plus 5x plus sine of 3x minus 5x dx. So this is equals to, take the half outside so that you don't get confused. So this is integral of sine of 8x plus sine of negative 2x dx. Now, this is equals to 1 over 2, the integral of sine of 8x dx plus the integral of sine of negative 2x dx. Please help me, Ishe. How do we integrate this? The first one, we forgot a half here. How do we integrate the first one?
Is it not?
We'll introduce a 1 over 8 and 8 over 8.
Thank you. So we introduce an 8 over 8.
Yes. Then it will be yes, like that.
And then here, what do we do?
We introduce negative 2 over negative 2. Or
Negative
2 over 2.
negative
Yeah, negative 2, yes.
sine of negative 2x dx. Okay. I'm following you. My mind is not here. So meaning here we take out the, so this will be 1 over 16. Is that what you're saying?
Yes, 1 over 16.
Mm-hmm.
And then we'll just get this one instead of sine x, we'll put cos 8x.
Okay, so meaning we're integrating. Okay, let's just write it again. 8 sine of 3, 8x dx. So this will be what?
The cos of 80, cos of 8x, if we integrate it.
Cos of 8x.
Yes.
Not negative.
You mean,
It's negative.
yeah, I mean negative, sorry.
It's negative.
Yes, negative cos.
So
Are you
this,
asking about the term or
You're
what?
asking about the one that you write or the one that you plus the half?
you guys
and
are
then-
giving me answers. You're supposed to be giving me answers.
Oh,
It's supposed to be negative
okay, no,
1
it will
over
be
4.
plus half into a negative 2,
Plus half,
and then integration sign,
integration sign,
negative 2,
negative 2.
sine 2x, sine negative 2x.
Something is missing. What did you do there?
The negative 2 is supposed to be 1 over 4.
1 over 4.
Oh, yes.
With the negative.
With the negative. Yeah, guys. With the negative, okay. And then?
And then would be,
Now we integrate.
Okay, so that's, give me answers.
So the first integration will be negative cos 8x over 16 minus
Negative
minus
cos of
8x
8x over.
over 16.
Mm-hmm.
Then minus to in fact it will be plus cos,
Why?
because when we integrate sign, oh, we have the negative already, so it will be positive. No, it will be negative.
I'm keeping quiet. I'm keeping quiet so that I get an answer.
A quick one. Is it possible to integrate the negative, like, I don't know, the sign with the negative 2x inside? I don't know. Is it possible to remove that negative inside?
Where are you
If I may
taking
ask?
it?
Like, I don't know. Is it possible? If it's not possible, that means my answer will be negative 1 over 4 times plus negative 2x.
Cos of 2x.
Negative.
Negative 2x. That's what you're saying.
Yes, ma'am.
Let's multiply inside and see what, let's differentiate this and see what happens. If we differentiate this, what do you have?
If
Do you
we
agree with the
differentiate,
answer or not, guys? Huh?
Mm-mm.
I don't know. I'm asking, do you agree with the answer or not?
let's do it together, man. Let's do it together.
Okay, differentiate this. Let's see what you have. Differentiate what you get, the final answer. That's how you can prove it. Differentiate it.
Okay.
If we differentiate the first one, what do we get?
we get is it 8? 8 8 sine 8
So
over.
we have 1 over 16, and we want to differentiate cos. Okay, there's a negative. Okay. Negative here. Let's put it like this. Negative cos of 8x. Cos of 8x. Differentiate this. What do you get? You get 1 over 16, right? Times the derivative of 1 over 8. No, sorry. Times the derivative. What is the derivative of this, guys?
Sine. It's
It's 8
negative
sine.
negative 8 sine 8.
Thank you. So it's negative 8
Sine 8x.
sine 8x. You guys are confusing me. It's, look at this. Negative,
be
right? The derivative
Yes.
of cos theta, it's negative sine of 8x times 8.
Yes.
So this becomes what? This becomes 1
1 over
over
2
2 sine
sine
of
8x.
8x. So let's go. Does it become 1 over 2 sine of 8x? Which is this one over here. Do you see that?
Mhm.
It means the
Yes.
first one is correct. Let's go and check
Yes,
this one.
that's
Let's check this one. We have negative 1 over 4 cos of
Negative 2x.
negative 2x. So the derivative of this becomes what?
1 over 4.
Mm-hmm.
The derivative of cos, the whole thing is going to be negative
Cos.
2 sine 2x.
Mm-mm.
Let's say cos into negative 2x.
Cos. Okay.
Positive.
Please
It's going to be
differentiate this,
positive.
guys.
Positive
This
2
one.
cos
Negative.
2x.
No, it will be sine. Yeah, sine into negative 2x.
2 sine 2x, yeah.
2 sine
2x.
negative 2x.
Yes.
Do you see that? So this becomes what? Negative 1
And
over
you forgot,
2 sine of. I
Yes.
you
forgot
forgot
what?
the negative.
How?
The
No,
negative.
it's right. It's right.
Cos, the
Look at
negative.
this, right? So this becomes negative sine of negative 2x times the inside function, the
Negative 2.
derivative of the, which is negative 2.
Negative
Do you
2,
see that?
yes.
So this
Yes.
becomes negative 1 over 2. This and this becomes positive. So then it
Yes.
becomes 1 over 2
Yes.
sine of negative
Negative.
2x. Now
Mhm.
this, is it equals to the one on top here?
Cos 2x.
That's correct, yes.
Do you see that it's not equals to that?
The problem is the negative, the sign now.
It's the sign now.
Yeah.
So meaning that here it has to be positive. So where did we go wrong?
Hold down, ma'am.
When we were differentiating.
Okay, let's
When
put it
we-
negative
when
because
we
that's what we
integrated.
got first.
It was supposed to
Negative,
be negative,
yes.
and then we'll get a positive answer.
Uh,
Then can you scroll up a bit? Can you scroll up a bit? I want to see something.
where did we go wrong?
There, I think here, ma'am, when we had our negative 2 over 2, we didn't take out our negative outside. That negative 2 should be negative there.
We did.
When we have our, oh, we did, yes, we did.
When we're integrating sign, we didn't put negative. Did we put negative?
We
just
did.
said
No, we didn't. Yes.
we didn't.
We did not we did not put
For
when
the-
we integrate sine, it's negative cos. So it's gonna be negative and negative.
Yes, it's going to be negative 1 over 4 multiplied by negative cos.
So it's multiplied by negative cos.
Yes,
So then
Yes.
this becomes positive.
positive.
Thank you. Thank you. Always, guys, try to differentiate this and see if you go back to your original. Does it make sense?
Yeah, it makes sense.
Yes, ma'am.
Thank
Yes,
you.
ma'am.
Thank you very much. So where were we?
Wait.
Yeah. Thank you. Okay. Now let's look at, I think we are done. Are we not done, guys?
Yeah.
Oh man, we are not done, man. We are not
Example
done.
You telling me you can't go and do example 9 by yourself?
Okay,
Hey
but
man, we already seen flames with 8. What makes you think we'll be stronger with 9?
No, you are, guys. No. Then I'll take it out in the assignment.
Ma'am, we
Okay.
heard you. We heard you, ma'am. You do the examples, we do the activities.
Yeah, you see, when something is recorded, you can't even go back. Hey, next time we talk before we stop the recording, then talk after. So
There's
that
no
there's
talking
no
outside here, man.
So that there's no evidence. Okay, now which one is this one? Which one is this one? Let's look. Let's all look. Number 1, number 2, number 3, number 4.
Number 3.
So meaning that
3.
it's what,
Number 3.
6 and 4. So this is the integral of cos of 6x times cos of 4x dx. This is equals to the integral of 1/2 cos of 10 6x plus 4x plus cos of 6x minus 4x dx. Now this is equals to integral 1/2. Do you see it's the bracket that covers everything, guys? Hey, the mistakes you guys do in the exam. Don't come drinking, guys. And then this is 2x dx. Now, we can separate the integral sign and it comes with a half. So this is cos of 10x dx plus 1/2 integral of cos of 2x dx. Now, before I match, okay, let me not give answers. What's missing there? Yeah? What's missing? What's missing, guys? Hello?
Yes, we're still here, man.
Should I just give my own answers? Oh,
No. Let's just figure it out. Okay, so cool. You took the half outside of the integration.
So I chose white. I'm writing the answers in white since you guys don't want to write. I'm writing the answers in white.
Nothing is missing so far, ma'am. So what's left is to integrate.
Okay, then give me the answers since you're saying nothing is missing.
The integral of cos is going to be should we do it step by step or the whole
Let's
answer?
do it step by step.
Okay, 1/2
Mm-hmm.
open bracket. The integral of cos is gonna be cos what? Sine 10/10.
Sine 10/10.
Yes. 10 sine 10x rather. It's 10 sine 10x.
Okay. Remember we said that it should be the integral of f of prime of x cos of f of x dx.
Yes.
And in this case, our f of x is what? 10x. So meaning that it should be the derivative of 10x, which is 10 cos of 10x. So meaning we're missing a 10. So we introduce 10/10 here. And here we're missing a 2. So it's 2/2. So then this will be equals to 20. Right?
Yes.
The integral of cos of 10 10x dx plus 1/4 integral of 2 cos of 2x dx. So this is equals to 1/20. Then this becomes what? What is the derivative of the integral of this? It's sine
And sine.
Sine 10x
plus
10.
1 over 4
Mhm.
sine 2x plus c.
Let's see.
Next.
Next. Using next in line. Go. Done.
No, we're not done, man.
How are you not? These are post tests. They say you have now completed learning unit 2 trigonometric integrals. You should be able to solve the integrals of powers of trigonometric functions using trigonometric identities, solve integrals of products or trigonometric functions using trigonometric identities. We now move to learning unit 3, which is trigonometric integrals part 2.
Man, you're too fast. Let's go back. We were very fast. Oh, where was that? Oh, man, I need to understand that. You're too
What is
fast.
the or? Let's
man.
fix the or, guys.
Yeah.
What does or mean? Let's fix the or.
Or
To a
in
5-year-old.
English. Huh?
Are we still explaining to a 5-year-old?
Yeah, like how we simplified or.
Either
Can't
you
use special
or
words like either.
can use what?
You can't use special words like either.
Okay,
What does
to a
or mean?
5-year-old.
Yeah.
It's this or that.
You're using or, like that's not an explanation.
Oh.
It's like what's this? It's like
either you have an apple or an orange.
You're
Choose
still
one.
using or.
Okay, you can only have one.
Yeah.
It
Only
means
one.
you can only have one.
But what if you have both?
You cannot choose both. When you use or, you cannot choose both. You can only have one.
So, ma'am, do we explain it in terms of math that or?
We
let's
explain
do
it
it
in terms of a
maths.
Yeah,
5-year-old.
let's do it in maths. I think it'll be easier.
Or is that tension? As simple as that, and the difference.
Because what I don't understand is, what if you have both? Does that mean I can't apply that expression? I can't use that identity.
Okay.
There is a part of both, and there is a part of or, which is and. And is for both, or is for one.
No, that one was for even numbers. What if both are odd numbers? Does that mean I can't use that identity?
That's where n comes in. There
You
is a
guys
rule
are
for when
debating.
both-
Let me stop the recording.
I remember you didn't do that example. We still have 10 minutes, man. Why are you in a hurry?
Which example? I did the example.
I
all
know,
the
man. No, you didn't do number. Did you do number 6? No, you didn't do number
All
6,
of them. I
man.
did number 6. Which is number 6? Timbo?
The one that affiliated with or. No, ma'am, you didn't do it.
I did the example. I just asked the question. And that you guys need to go and sit down
Yeah.
and ask yourselves.
Okay, ma'am, explain to a 5-year-old what does or mean.
I don't know.